In this video, we will be pinning a virtual machine to a specific set of CPU cores using Proxmox. I've created the virtual machine 104 for this example. If we switch to the terminal window behind Proxmox, on the right-hand side, I've opened up HTOP in the virtual machine, and we can see it has a total of 10 threads. If I stress those threads, we can see them go up to 100%. On the left-hand side, we can see I have HTOP running on the Proxmox host, and we can see the virtual machine threads bouncing around from CPU core to CPU core. We want to be able to pin these threads to a specific set of CPU cores. We use the taskset command to do this. Taskset has two primary things that we need to care about, which are the process CPU core numbers that we want to pin the process to, and then the process ID. QEMU server keeps track of the process ID for virtual machines, the parent process ID, in this /run/QEMU server/ID number of the virtual machine .pid file. We're going to read that file out and send it to the taskset command. When I hit this enter key, we will see all of the threads for the virtual machine pinned to the first 10 CPU cores. Now we want to be able to automate this process so that every time a virtual machine starts, it will be pinned to the specific set of CPU cores that we've defined. Now, Proxmox has a way to do this using a hook script, but there's no way to add a hook script from the user interface. If I click on my workstation 101, we can see that I've defined a hook script here, but there's no add button. So we have to modify the configuration file for the virtual machine in order to add the hook script. A hook script is run whenever a virtual machine is started or shut down, and it allows us to hook into different phases of the virtual machine's lifecycle: startup, shutdown, etc. We're going to modify the configuration file for virtual machine 104. So we're going to go to another terminal, and we're going to edit that file under etc PVE QEMU server 104.conf. At the bottom, I've commented out the hookscript line that we need to add. Hookscript is defined as being a file on the local data store for Proxmox, which is default on all Proxmox installations, in a folder called snippets with a file called simple taskset hook.sh. If I save this file, we can go back over to the user interface, and we can see the user interface has detected that change to the file and has added the hook script here. Now we need to go to the local snippets folder in order to create this taskset hook so that the virtual machine can use it. The local data store is by default under var libvz. If I look at this directory, I can see dump, images, snippets, and template. You may have to create the snippets folder yourself. cd into the snippets folder, and then we're going to create our taskset hook file. Now I said that the taskset hook script runs whenever the virtual machine is launched or is shutting down, etc. It's a hook script that lets us hook into different phases of the virtual machine's lifecycle. So the hook script is provided with two variables or two arguments when it's launched. The first argument is the VM ID, and the second argument is the phase that the virtual machine has entered. So if the virtual machine has entered the post-start phase, that means that the virtual machine has a process ID that exists because it has started, and we can then limit that process ID to being on a specific set of CPU cores. We have a default value here for CPU set of 0 to 9, just so that we can easily make this change. Now there's one more thing that we have to do for our taskset hook script to be usable by Proxmox, and that is we have to use chmod to add the executable bit to our taskset hook script. If we don't do this, then Proxmox will not be able to execute this script as an executable file and will fail to start your virtual machine. That's as simple as it is to set up a very simple taskset hook script in order to pin the CPU cores, or pin your virtual machine to a certain set of CPU cores. Now what if you want to do it for all your virtual machines and you want to use different sets of CPU cores for each virtual machine? Well, we have an advanced taskset hook script for that. And oh boy, it looks way more complicated. It's not. So what we've done here is we've modified that first simple script with a couple more if statements. The if statements check and see if a certain file exists And if it does, then it replaces our default CPU set. Remember, our default CPU set here is 0 through 8, and that's what taskset is going to use to pin your virtual machine's thread to a specific CPU set. So if we overwrite this variable with some other value, then taskset will simply use that overwritten value. So this script will look for two different files. The first file it will look for is in that same directory, etc PVE QEMU server, and then vmid, but instead of .conf, it's .cpuset. So if that file exists, then we're going to grab the contents of that file and store it in our CPU set variable. If this virtual machine, this vmid, does not have a CPU set file, then look for a default CPU set file, and if that default file exists, then overwrite our CPU set with the default file instead. Do the same thing, close this file, make it executable. I'm going to show you under etc PVE QEMU server. If I do ls, you see I have a default CPU set value here, and a 101 CPU set value here, and a 152 CPU set here. If I cat out 152, you can see all it is the CPU set. It's just the values of what CPU cores I want this virtual machine pinned to. So to sum up, in order to pin a virtual machine to a specific set of CPU cores, you need to make a hook script that calls taskset to limit the number of CPU cores that that virtual machine is pinned to. And if you want it to be available to all of your virtual machines, make a default CPU set, and make CPU sets for any specific virtual machines that you want exceptions to the default CPU set for.